In section 2.2, we're going to talk about circles. I have to admit, this is one of my favorite topics to teach, so you might hear a little extra enthusiasm in my voice. The equation of a circle that has its center at the ordered pair h, k, and that has radius equal to r, has the following equation. X minus h quantity squared plus y minus k quantity squared is equal to r squared. This equation is actually the distance formula. If you compare what we see here to the distance formula that we saw in the previous section, you're going to see that the similarities are almost exactly the same. The distance formula, which I'll repeat here, says that the distance between 2 points is equal to the difference between the x coordinates squared plus the difference between the y coordinates squared, and then you take the square root of that sum. Well, that's exactly what we have here if we were to raise both sides of the distance formula to the second power. In essence, we would have distance squared is equal to the sum of two differences that are being squared. Here, x2 is replaced with just the letter x, x1 is being replaced with the letter h, y2 is simply y, and y1 is acting like k. Distance, of course, is acting like the radius r. The reason these two equations are so similar is that they are indeed one and the same, just with different letters. I've prepared an example here off to the right to show where this equation comes from and why it is nothing more than the distance formula. By definition, a circle is the collection of all points that are equidistant from a fixed point called the center of the circle. Equidistant, of course, means the same distance away from. In this example that I have drawn in advance, we have a circle centered at the ordered pair 7, 7, and with a radius of 5. If we were to apply the distance formula to the point 7, 7 as one of the endpoints of that segment, and x, y as the other endpoint of the segment, we would say that the distance between these 2 points is equal to 5. But the radius is equal to the distance between any of the points on the circle and that fixed point called the center. So I'm going to add another radius here. It will also have a length of 5, and the endpoint is going to have different coordinates than the one above, but that's why we use x and y, because they are variables that can take on different values. You can imagine that this red segment representing that radius can be circulated all the way around so that the endpoint of the segment can be any of the points on the circle itself. So again, let's use the distance formula here. Distance is equal to the difference between the x coordinates squared plus the difference between the y coordinates squared, and then we would take the square root of both sides. In this case, the distance is equal to 5, and if we were to square both sides, we would get that 5 squared is equal to x minus 7 quantity squared plus y minus 7 quantity squared. And voila, we have the equation of the circle. I'm going to write it in standard form so that it matches the format to the left. But what we have here is the equation of this circle that is centered at 7, 7 and that has a radius of 5. So back to the equation of the circle. The center of the circle will have coordinates h and k, as we see here. The radius of the circle is equal to the distance between the center of the circle and any point on the circle. And we see here that this is indeed a version of the distance formula. Now, all circles can be centered at any point on the xy plane. If the center of the circle is actually the origin, then h and k will essentially be 0 and 0. In the event that the circle is centered at the origin, the equation simplifies to simply x squared plus y squared is equal to r squared. Because, of course, x minus 0 simplifies to just x, and y minus 0 simplifies to just y. Let's take a look at another example. We're asked to find the center and the radius for the circle, the center radius form of the equation of a circle, where the center is at 3, -7, and the radius is equal to 5. So in this case, h is equal to 3, k is equal to -7, and r is equal to 5. If we substitute these values into the equation above, we get x minus 3 quantity squared plus y minus a -7 quantity squared is equal to 5 squared. Let's clean this up a bit so that it looks more simplified. The equation of the circle is x minus 3 quantity squared plus y plus 7 quantity squared is equal to 25. Let's work another example. Here we have to find the equation of a circle that is centered at the origin, so that means that h and k are both 0, and the radius is 3. Now, you can go through the original equation and then simplify if you want to see the connection, or you can jump right to this second equation that is the simplified version when the center is at the origin. Notice that we just get x squared plus y squared is equal to 9. If you're able to remember that when the center of the circle is at the origin, the equation simplifies very nicely, you don't have to go through this first intermediate step. Next, let's find the equation for the circle that has its center at -3, 2, and that passes through the point 2, -4. Now, unlike the previous problems, we have a little bit of prep work to do because we're not given the length of the radius. We're going to have to compute that, though. Notice that the distance between the center of the circle and the point on the circle 2, -4 does represent the radius. So finding the distance between these 2 points will be the same as finding the radius. Let's do that first. We know that -3 is like our h and 2 is like our k. Let's label that and save it for later. Using the distance formula, we find that the radius is equal to the difference between the two x-coordinates squared plus the difference between the two y-coordinates squared, and then we'll take the square root of that sum. Let's continue simplifying. We find that the radius is equal to the square root of 61. We cannot simplify the square root of 61 any further because 61 is not a perfect square, nor does it contain any factors that are perfect squares other than 1. Resist the temptation to give an estimate for the square root of 61 by converting it into a decimal. Instead, let's keep this as an exact answer. Now, to find the equation of the circle, we now go back to the form x minus h quantity squared plus y minus k quantity squared is equal to r squared. After simplifying, we have that x plus 3 quantity squared plus y minus 2 quantity squared is equal to 61. This is the equation of the circle centered at the point -3, 2 and with a radius of 61. This is considered standard form, so there's no need to go ahead and multiply out what x plus 3 quantity squared is or what y minus 2 quantity squared is. This is the best way to leave the equation. Next, let's find the equation of a circle that has a diameter with endpoints -3, -1 and 5, 5. In this case, we have to find two missing pieces. We don't know the center of the circle either. So we're going to have to find that by finding the midpoint of this diameter. Remember that a diameter extends from one point in the circle to another point in the circle passing through the center. So finding the midpoint of this segment will be the center of the circle. Additionally, we'll have to compute the radius of the circle. We can do this a couple of ways. We can either find the length of the diameter by using the distance formula with the endpoints and then remembering to divide the diameter by 2. Or we can find the center first and then find the distance between the center and either one of these endpoints. Both methods are acceptable and they both should be to the correct answer. So first, let's find the center of the circle by computing the midpoint of this diameter. Recall that the midpoint formula calls us to add the two x coordinates and divide by 2, and then add the two y coordinates and divide by 2. That means the center is going to be at 2/2 and 4/2, which simplifies to 1, 2. That means the center of the circle is going to be located at the ordered pair 1, 2. 1 is like our h, 2 is like our k. Next, let's find the radius. Again, you could find the diameter first and then divide the diameter by 2, or you can find the distance between the center, which we now have, and either one of the original endpoints. Let's use that second method and say that the radius is the distance between this center and let's use 5, 5. Again, we're going to subtract the x coordinates and square. Add that to the difference between the y coordinates and square, and then we're going to take the square root. We see that the radius of the circle is equal to 5. Now that we have the center coordinates and we have the radius, we're ready to substitute these into the equation of a circle. We have x minus h quantity squared plus y minus k quantity squared is equal to radius squared. This should be your final answer. Lastly, let's practice how to sketch the graph of a circle given its equation. This is actually quite simple once you understand how the equation relates to the anatomy of a circle. In this first example, we have that x squared plus y squared is equal to 9. The center is clearly the origin. The radius, when squared, is 9, so the radius itself must be the square root of 9, or 3. Now I'm going to do this by hand to show you don't have to be perfect, and you can give a basic graph of a circle by using some guide points. First of all, I like to start with plotting the center of the circle. Then, using the radius, I can travel 3 units up, 3 units down, 3 units right, 3 units left. And although this is not going to be perfect, I can use these 4 points as a guide to get the basic shape of that circle. In the next example, we see that the center is h, k, where h is, well, this is like x minus 3, or rather x minus a negative 3. So h will be a -3, and k here will be a 4. Remember that h and k are being subtracted from x and y respectively. So if you see addition, we're really subtracting a negative number. The center here is -3, 4. Right there. The radius is equal, in this case, when squared, it's 36. So the radius will be the square root of 36, or 6. So from here, we can travel 6 units up. We can travel 6 units down, 6 units to the right, and 6 units to the left. And using these as our guides, then we can get a basic idea of what that circle is going to look like. In my math lab, you'll have a graphing tool that will allow you to have perfect circles.